What we're going to be talking about today is really synthetic division, but I want to start out by kind of refreshing our memories of what we did basically at the end of first semester where we did long division. And so what we have right now is we have this division of a polynomial by a binomial. And what we did first semester to set it up is we would put the x plus 3 on the outside, and then the numerator would go underneath. And there were really about 3 basic steps that we took to do long division. That was divide, multiply, and then finally a subtraction part. And what happened is to divide, we would take the first term of the numerator and divide it by the first term of the divisor. So you would have 2x cubed divided by x, which would be 2x squared. And we take that 2x and we put it up here. And then we'd go to the multiplication step. And what the multiplication step did was it took this number right here and it multiplied it by the divisor. So we get 2x squared times x plus 3, and that gives you 2x cubed plus 6x squared. And what we do is we take this and we put it underneath the numerator, and we come to our final step, which would be subtraction. And we'd subtract that quantity. And the idea is that that first term would cancel out, and then we'd subtract the second, and we get 7x squared. And from there, we drop down the next term, and we repeat the process again. But this time, when I go to divide, I want to use this first term, which is 7x squared, and divide it by x. And once I get that 7x again goes to the top, and it's positive, so I'm going to put plus. And I'm going to take that 7x, and I'm going to multiply it by the x plus 3. And we get 7x squared plus 21x. And I just keep repeating the process. 7's cancel out, and I'd have 9x. Drop down the 25. I'm going to start over. 9x divided by x is 9. So I put that 9 up there. 9 times x plus 3 is 9x plus 27. And then finally, I'd subtract. And I get negative 2. This negative 2 right here sorry about that. This negative 2 right here is called the remainder. And what we do with that is we're going to bring it back to the top, and that's going to go over the divisor. So our final answer is actually this big long piece right up here, and that will be 2x squared plus 7x plus 9 minus 2 times quantity x plus 3. Now that we've done it by long division, we're going to show you a shortcut. And this is called synthetic division. And how you set up synthetic division is when you have a binomial like we have, you're going to take the binomial and you'll set it equal to 0. And you're going to solve for x. So x equals negative 3. And what I'm going to do is I'm going to place this negative 3 kind of in this little box in the upper left-hand corner. And then what I'm going to do is I'm going to take all the coefficients from my problem in the numerator. So I'm going to take 2, 13, 30, and 25. And again, these came from the original problem right here, and it came from all the coefficients. And I want you to take a quick note. Notice that I'm using all the signs. These just all happen to be positive, and that they go in order. So it goes 3, 2, 1, and then nothing. So it goes right down the line. So I line those up, and I'm going to draw a line underneath here because we're going to leave a little space. What's going to happen is I'm going to drop this 2 down. This is going to be my starting. And what's going to happen is I'm going to multiply the -3 times the -2. So multiply this, and that's going to give me -6. I'm then going to add these together, which is 7. So 13 minus 6 is 7. I'm going to repeat that process. -3 times 7 gives me -21. 30 minus 21 is 9. Keep going. -3 times 9 gives me -27. And 27 minus 20, 25 minus 27 is -2. Get rid of some of these lines real quick. And I hope you kind of see what ended up happening. If we kind of zoom out and look at our answer to the long division, all of these coefficients are the same as what we have over here. And that's going to happen. This is a shortcut for long division. This right here is going to be your remainder. So the very last number is going to be your remainder. And then everything else kind of follows backwards. So then the next number will be our constant. The next term will have a degree of 1, and the next one will have a degree of 2. So 2x squared plus 7x plus 9, and then I'll do -2 over my divisor, which is x plus 3. Take a look at number 2. Set it up for long division. I'm sorry, not long division, synthetic division. Pause the video and see if you come up with the same answer. A quick hint before you start, notice that this jumps from 3 down to 1, so think about how you might fill that in. You can take a look at how I filled that in real quick. Because it goes from a cubed down to a to the first, I can use a placeholder of 0 for the a squared. And what you should have gotten is 3a squared minus 6a plus 10 plus 1 over a plus 2. One theorem that we have in this chapter is called the remainder theorem. And what the remainder theorem states is if the polynomial f of x is divided by x minus k, so a binomial where k is a constant, so a number, then the remainder is equal to f of k. So I want to go back to the example we just did, number 2. If we take a look at what the remainder was 1. And based on this remainder theorem, what it's saying is that if I take -2, because if you think about a plus 2 and we solve for a, so if I take -2 and I plug it into the function 3 -2 cubed minus 2 times -2 plus 21, I hopefully will get the remainder, which is 1. So again, if I take the k value from the binomial, plug it into the function, I should get the same remainder as I did in synthetic division. So if we go through this, -2 cubed will be -8 plus 4 plus 21. That's going to give you -24 plus 4 plus 21. -24 plus 4 is -20 plus 21. That is 1. So again, you can see how that ends up being the same. If I just plug in the number, I can get the remainder. Or if I go through synthetic division, you can see that I can figure out the remainder right there. Number 3 is asking you to use synthetic division to find out what the value of the function of f is at f -2. So go ahead, pause the video, and use synthetic division to do that. So your remainder should be -45. So when you have an input of -2 into the function, you'll get an output of -45. What we have right here is we have the definition for a higher degree polynomial function, and it just shows you the notation of it, where a of n and a sub n minus 1 and so on, those are our coefficients. A sub n, that very first one, is called the leading coefficient. You'll need to know that as a definition. Leading coefficient. N is the degree of the polynomial. So whatever that highest exponent is, that's the degree. You'll need to know that also as a definition. And a sub 0 is the constant term. And hopefully that's something that we know already. But that is a vocab that you will have to know as well. So constant term. Another term that hopefully we remember is 0 of a polynomial function. It's also the root or solution. And basically what that says is a value of k such that when you plug in k into a function, the result is 0. And you can see that by this notation right here. So when you plug in k into the function and the result is 0, that means it is a 0 of the function, or it could also be called the root or the solution. Again, some vocab that you'll kind of need to know for this chapter. What you're going to do with number 4 and number 5 is that you are going to use synthetic division to determine if the numbers are indeed zeros of the function. So you'll figure out that they're zeros that if the remainder ends up being 0. So go ahead and pause the video and try number 4 and number 5. You can see in number 4 that our end result is a 0. So this would be yes. 2 is a 0. If you start number 5, I'm guessing maybe some of you had a little trouble with that, because what we're using is we're using imaginary solution to see if it's a 0 for the function. I'm still going to set it up the same way. The 2 minus I goes in the upper left corner. I'm going to drop down that 1, and I'm going to multiply, or what I did is I took the -2i and I times it by 1. That's how I got this right here. So I want to continue with that idea. And what we do now is we add these two together. And what you're going to get is 5 minus I. And from there, just as we did in the other ones, I'm going to take this number and I'm going to multiply it times our the number we're seeing if it's a 0. So I have 2 minus I times 5 minus I. And notice they're both binomials. So I'm going to have to FOIL it and see what I come up with. I squared, if you remember, becomes -1. So I have 9 minus 7i. I'll add those together, so I get 13 minus 7i. And you can clearly see that the remainder isn't 0. So no, it is not a 0.